It's z-scores all the way down. What do I mean by that? Suppose z is a standard normal random variable. Then z squared is distributed chi-square with 1 degree of freedom. That's simply the name we gave to the distribution of a standard normal squared. If you add up n independent chi-squareds with 1 degree of freedom, you get a chi-square with n degree of freedom. So it's the sum of n independent z-squareds. If you were to take this and divide by n and take the square root, if you're dividing by n, you're taking the mean. And then if you're doing the square root, it's the root mean square of the z's. So a t-distribution, which is defined to be a standard normal over the square root of a chi-square with n degrees of freedom over n, really it's the z over the root mean square of the z's. And finally, an f-distribution, chi-square n1 over n1 divided by chi-square n2 over n2, well, that's taking the squares and taking the average. So it's the mean square. So you've got mean square n1 and mean square for n2. And that's exactly what you're computing when you're doing an f-distribution. I just find it helps conceptually to tie it all together and think of everything as functions of z's. It's z-scores all the way down.